Before I begin today, before I introduce our speaker, I'd like to share a little background on the CMUQ Distinguished Lecture Series. At this campus, we host experts in many fields of study, many of whom are scholars and researchers at our main campus in Pittsburgh. We created the Distinguished Lecture Series to share the scholarship with the Cutter community. Today's discussion is a Gloriana St. Clair Distinguished Lecture in the 21st Century Librarianship, named in honor of CMU Dean of Libraries Emerita, Gloriana St. Clair. Gloriana St. Clair led the transformation of Carnegie Mellon libraries into the 21st century, supporting and serving both CMU students and our research community. Our guest today continues this tradition of innovative librarianship. Sayeed Choudhury joined Carnegie Mellon last August in the newly created role of Director of the Open Source Programs Office. Sayeed has previously served as Associate Dean for Digital Infrastructure, Applications and Services at the Sheridan Libraries of Johns Hopkins University, and he was a President Obama appointee to the National Museum and Library Services Board, and has served on several national committees that promote open science. Today, Sayeed will share his thoughts on open science, how it impacts researchers, the public, and the research infrastructure. So please join me in welcoming Sayeed to CMUQ.
Thank you, Mike, for that introduction. I should mention to you that when I've traveled, I found the second night is when I feel jet lag the worst. And that was last night for me. And I only mention this because it would be one thing if you fell asleep while I was talking. It would be quite another if I were to fall asleep. But we will proceed and see how this goes. So I did use the title Case Studies in Open Science. I probably should have more accurately called it Stories about Open Science. And I mentioned stories not because they're any less important, but actually in many ways I found the most compelling researchers are great storytellers. So what I'd like to be able to do, I hope to be able to do, is give you some of the stories from the perspective of those researchers who have made open science possible, and some experiences at my previous institution at Johns Hopkins and more recent ones at Carnegie Mellon, but also stories about how that has impacted other researchers and members of the general public. But a little bit of background and context before I get to the stories themselves. I've been spending the last few weeks looking into resources around open science in the Arab world, in the Middle East and North Africa. And not surprisingly, there's been quite a bit of activity, quite a bit of interest in this. This word cloud is not meant to be comprehensive. I did not look at everything that has been produced over the last 2 or 3 years, but I hope somewhat representative and somewhat illustrative of the existing interest. So I know I'm speaking to an audience of people who may know something, a good deal about open science, but I'm hoping that I can bring a different kind of perspective into the mix and how it might fit into what you're thinking. It's also worthwhile to think about what is open science. We're very fortunate to have 2 organizations, maybe others, that have provided definitions fairly recently. So I'll let you read this as I go through these slides. So this is from UNESCO, which has produced a report and a set of recommendations around open science. A few key highlights that I think are important to look at. The multilingual aspect, of course, but the accessible, open, transparent aspects, I think are key characteristics. And then the second part of that definition goes on to talk about multiple disciplines. So we use the term open science. Actually, in some contexts, at least in the US, we've been using the term open scholarship to connote that it also includes the humanities, the social sciences, the engineering, and other types of disciplines, and interdisciplinary types of work in particular. And that you can see some of the other components that are important in the way that UNESCO defines open science. And then even more recently, the Biden administration in the United States wrote what is called a fact sheet. So it is not a policy or a memo, but rather an expression of importance coming out of the White House, where they use this definition for open science. You'll see a lot of similarities to the concept in the UNESCO definition. But in the US context, this is particularly important because the federal government doesn't always provide definitions for things like this. So the fact that they're willing to give you an explicit definition is really critical. It's a signal to the federal funders that that the funders should start looking to this kind of open science in the programs they develop and the funding priorities that they have. So with that in mind, I'm going to keep coming back to this slide that I've been using a fair amount in the last few weeks and months. And these are what I call the 3 research objects that relate to open science. Moving from left to right in this diagram are articles, data, and software. And a lot of times when people talk about open science, they think mainly about the articles. And it is important, of course. So there's a lot of work that's happened around open access of publications that you may know. I know that CMU Libraries has been taking a lead in these so-called transformative agreements, which is really rebalancing how open publications are produced and then are accessed. But I'm actually going to spend more time looking at the data and the software piece. And part of the reason for that is the memo that I talked to you about is the culmination of 2 other memos from the United States administration that have been memorandum out of the Office of Science and Technology Policy. And these memorandum are progressively moving from left to right in this diagram. So it began with articles, most recent one has talked about data, and they're now looking for guidance around software. So let me move a little bit into conversations around that middle piece of what happens when you make data open, right? So you may recognize this. This is the final screenshot of the Johns Hopkins COVID-19 dashboard. It was just retired on March 10th. I had the privilege and honor of leading the library team that supported this COVID dashboard. I will tell you a true story. So Lauren Gardner is the professor who led this effort. It was her graduate student, Frank Dong, who actually came up with the idea to do this. And Lauren and Frank apparently talked about this over coffee. And Frank said, well, why don't I just set something up on the library's GIS system and we'll just put it out there and see what happens. And this was on Saturday, January 20th, I believe was the date, or maybe the 22nd. And I saw this over the weekend. And I contacted our manager of data services, and I wrote her an email. I said, so I noticed the COVID dashboard thing is on the library infrastructure. Do I need to know anything about this? Do we need to worry about server capacity or anything? And she wrote me back. She said, no, I've communicated with Lauren. This is just a research experiment. They think it'll be taken down by Monday. So that clearly did not happen. This went, pardon the pun, viral. And was, of course, adopted by the entire planet, it seemed. There were days when there were more views of this dashboard than there were Google searches, just to give you some context of what happened. But it is, in many ways, quite an accomplishment in terms of open data. So early on, the commitment was made to share the data, to share the process data in an open manner. I'm very proud, I guess I'll say, that I was the person that first suggested using Creative Commons licenses for the data that were being produced. So this is an organization that produces a set of licenses that were initially targeted for articles so that you could share them openly and you could discover them through searches, increasingly being applied to data. So we used those kinds of licenses for the data that was being managed through this dashboard and presented through this dashboard, and it led to a series of other uses. Now, one interesting thing is that we asked for attribution. So whenever people would use the data and produce their own kind of dashboard, it would say credit to Johns Hopkins University or based on data from Johns Hopkins University. And organizations like Google, the New York Times, other universities produced their own dashboards. But people kept coming back to this one. So the attribution kept reminding people of the original source, if you will. And in some sense, while the credit and the attribution was distributed, the credibility was not. And many people built very useful dashboards. I used to look at the New York Times one all the time. But everyone kept coming back to this one. So I think it was an interesting case of once you have that kind of credibility, even if you release the data, and even if it produces derivative works, people keep coming back to that primary source and recognizing and acknowledging that value. Now, some things I'm going to tell you about how this happened are not necessarily things we've shared broadly. So this was not planned, as you've gathered. Lauren and Frank thought it would be gone over the weekend. We found the following week that this was being used extensively. It was starting to be used by the US government. It was starting to be used by public health organizations and so on. We were not prepared for that, quite frankly. We just did not think that this was going to happen. As one of the team members said, we had to build the plane at the same time we were flying the plane. I was on call for several weeks from 2 a.m. to 6 a.m. in case something happened to the dashboard. So this was a significant effort, required all hands approach and so on. So there are a lot of lessons learned, if you will, about how we would have managed the data, how we would have asked others to produce the data. But nonetheless, we were able to process the data and present it in this way, make it open, create these dashboards, and create all these other dashboards that had been put forward. So it was a success story, but it wasn't necessarily an intentional strategic example of open science. So another group that I had worked with when I was at Hopkins is from the Physics and Astronomy Department, and it's a project called the Sloan Digital Sky Survey. At the time, it was the most extensive survey of the Northern Hemisphere of the United States for certain types of astronomy data. Within a couple of days, the Sloan Digital Sky Survey, or SDSS, acquired more data than the entire history of astronomy up until that point. And what this diagram shows you is the so-called data flow, going from the top left corner of this diagram, which they called level 0, to level 1, level 2, and then level 3, as you see in this diagram. And what I learned is the telescope at the top left corner, where the data comes out literally as ones and zeros, as bits, right? Level 0 data. I went to the Fermi lab, where most of these data were managed, and I met with a team, and they said, you know, there's probably about 12 people in the world who can interpret those data. And upon hearing that, my first thought was, you make sure these 12 people are never in the same room, or on the same plane. I mean, this seems like a fairly important point of vulnerability. And they said, we went beyond that. We knew that we wanted people to use astronomy data and to learn about astronomy. Now, Alex Saleh is the professor at Hopkins who I worked most closely with on this and is one of the principals for SDSS. He has this saying where he says, astronomy data is worthless. It has no commercial value, it has no legal implications, it has no medical restrictions. It's incredibly open. So this was a great opportunity to examine what does it mean to truly have open data, right? We weren't going to have companies coming along and saying, wait, we'd like to profit off of this. We weren't going to have the legal group at Hopkins come along and say, wait, there's patient information and so on. So from a very early stage, the astronomers said, how do we go from 12 people to a much larger audience that can use these data? And this data processing pipeline was built intentionally with that in mind. And by the time you get to the so-called level 3 data, which they call data releases, which by the way, they call it publication. That's the term they use. We publish the data releases. They're up to data release 18 now. They are available for the public, right? So if you go down this chart, level 1 you see is the Fermilab building where the processing happens. Level 2, when it's in these so-called Beowulf clusters, is when most astronomers can start to use the data. But level 3 are published on a website. They're available for anyone to use. So the intention from day one was how do we get from this very specialized set of data to data that are used by the public at large. And this is a really important lesson in terms of how we might approach open science. So what might happen, or what did happen when they took this approach? There's a project called Galaxy Zoo. I don't know if you're familiar with it, where you can go to this website and classify galaxies that have been imaged by the Sloan Digital Sky Survey. Now, at the time, they found that AI, machine learning, was not very good at classifying galaxies, but people are very good at classifying galaxies. So there's still some interesting problems where we continue to have an advantage over ChatGPT. So this resource was set up specifically for anyone to come along, go through a little bit of a training, not very long, and then have an account and look at images of galaxies and classify them, right? There was a Dutch school teacher who was doing this, and was using it, for her classroom. But she was also classifying the galaxies directly herself. And she found this green object in one of the pictures, right? And initially tried to classify it as a galaxy. And based on the training said, I'm not really sure what this is, according to the galaxies. And then wrote a message to the Sloan, the SDSS team, saying, you have an error on one of your images, right? There's some artifact or distortion you should look at. They went and looked at it. Despite every attempt to just dismiss it as an artifact, they said, this does not look like an artifact. This is something that was imaged. This is real, right? And the color is accentuated here to show it to you, but this was a real object. She had discovered an entirely new object, and it was named after her. So when I say Hanny's object, Hanny is the school teacher. So they decided, not only did you discover, what is not an artifact, you discovered a new object. We're going to name it after you, which of course is quite an honor for her, I suppose. But it also prompted further investigation. The Hubble Space Telescope was pointed at this region of the sky, and I trust the James Webb Telescope will be pointed at this region of the sky. So she made an observation, an actual scientific observation that prompted the entire community to adjust where they would get other new observations and study this object. And this has led to a whole series of literature around this new kind of object. Coming back to this diagram, if you look at these squiggly lines between the data and the software, that is my very poor attempt, I'm not an artist, to show that the relationship between data and software is very complex and multidimensional, right? So when you think about data and articles, it's basically a citation. It's like a one-to-one link. But when you think about data and software, I can gain tremendous insights about what kind of data you're using if I can see your code, right? So what happens if you move from opening up the data and allowing people to use it, to make observations, to make contributions, to giving them tools, to giving them code that allows them to do more interesting things, perhaps? Going back to the Sloan Digital Sky Survey, this is the website where you can go and look at these data releases or publications. As you can see, it is available. That data release 18 was just produced recently. This is a website where anyone can go and run analyses against the astronomy data. Now, I'm told there are about 10,000 professional astronomers in the world. There are over 1 million registered accounts for SDSS. They're not all active, but let's say half of them are. Let's say a quarter of them are. That is still a significantly larger number than professional astronomers, right? And I used to basically look at the list, the help desk for this SDSS project, and you would have school kids, teachers, members of the public, anyone just asking questions, running queries. The SDSS team monitors usage of this website, and for a time, they found that a high school in Florida was the second highest user. They assumed they were about to be hacked. So they shut off access to this high school. The principal of the high school then contacted them and said, "Are you crazy? I finally have students interested in science, and they're using real astronomy data, using your tools, and you just shut them off." So the astronomer said, "Well, we are sorry. We did not realize that was the case." To their credit, they've built an entire set of resources and tools aimed at school kids. So this is no longer professional astronomers. This is no longer amateur astronomers. This is no longer graduate students. This is 10-year-olds, 12-year-olds that are using these tools to conduct real analyses. And on this list, I would see questions about the data and about the tools, to me, that look like the current future version of reference questions, right? So you go to the library, you ask a reference question, you get help to navigate the information space. These questions, to me, look like what reference questions will be when we live in a data-intensive and a software-intensive world. And it was quite amazing to watch the process at which these questions would come in and they were answered. Now, there's an individual named Ani Thakar, who's an amazing person. He is the chief data scientist for the SDSS project. And when I first met Ani, I said, "What's your background?" He said, "Well, I'm an astronomer." He said, "Well, I used to be." I said, "What does that mean?" He said, "Well, Alex sat down with me one day and said, I'm sorry, Ani, you're going to have to give up your career as an astronomer. You're going to become a data scientist. You're going to be the person that leads the design of the databases, that works on these kinds of issues. And we will put your name on articles, but you're not doing any more astronomy. This is going to become your role. Now, Ani embraced this, and that's to his credit, but is that the model we want for scientific communities? That you take a member of your team and basically say, you don't get to do your science anymore. You're going to do the data work. Or is that something the library can pick up as an organization that develops the expertise and the skills to learn these things so that scientists can continue to be scientists? Another example, going back to COVID, is something that's been produced at CMU called Delphi. So this is a forecasting tool for COVID-19. So the dashboard at Hopkins basically gave you a snapshot of the number of cases, right, and the distribution of the cases and so on. Delphi is a tool that helps you forecast what may be happening. And when I say you, I literally mean you. Obviously, you can go to the Delphi website and look at their projections, but they've made all their tools and code available. So you can actually run the queries yourself. And you can actually produce projections yourself. This is the kind of thing that happens when you open up data, but also add the tools to it. Now, one thing that's kind of interesting to me is more people seem to spend time on the dashboard than looking at the projections, right? And I find that somewhat odd. I'd actually like to know what's coming, not what happened yesterday. So there's an education or an awareness building or sort of a capacity building aspect to this that I think is missing, right? We needed as many people to be concerned about forecasting COVID as we did reacting to COVID. It felt like we were very reactive throughout the entire process, at least in the United States. Delphi and other kinds of tools can allow us to be proactive and to anticipate what may be coming. And this is true of many, many sciences, right? And then there's the Cloud Lab at CMU. So if you're not familiar with this, there's a company based in the Bay Area in California called Emerald Cloud Lab that has built a facility that includes physical equipment, robotics, and code, and people walking around the facility and navigating the space as well, for small startups in life sciences to run experimentation remotely. So one of the first websites that I ever visited was a Caltech website where somebody had set up a robot which you could control remotely and blow a puff of air into a sandbox. Now, that's a fairly meaningless task, but it was really amazing that I could sit in Baltimore and blow a puff of air in a sandbox through a robot. Well, we've come a long way since then. Cloud Lab can do a lot more than blow a puff of air. It can run thousands of experiments with dozens of different types of experimentation and equipment. And code is very much the substrate that sort of brings all this together. So one of the things I'm hoping to do through the Open Source Programs Office and working with the Cloud Lab team is come up with a data flow diagram, just like we did for the, I mean, not exactly, but just like we did for the astronomers. What does the data flow look like? Right? What happens when we move from 12 people in the world understanding a data flow to dozens of people, hundreds of people, thousands of people understanding a data flow, saying, here's the instrument, here are the raw data that are produced, here's a data flow that allows many more people to become involved. This, to me, feels like SDSS amplified to a major kind of scale, right? And I'm glad to note the Cloud Lab team is very eager to explore this. Now, there's some practical reasons, there may be some financial reasons, but some of it has to do with the movement of what's happening with open science in the United States. The National Institutes of Health in the US just this past January issued an update to their data sharing policy, a very significant one, so that all proposals now require a data management plan. And I've spoken to people in the Office of Data Science Strategy at NIH who basically said, this is an inflection point. Prior to this new policy, if you had data that had been created from an NIH grant and you told us you couldn't share it, that was enough, because it could be patient data, it could be clinical data, so on. Now we're saying you have to tell us why. And you may have very good reasons why. There continue to be lots of reasons why you couldn't, but you need to tell us why. And the reason can't be, I don't want to, or it's difficult. Those are not good reasons. So if you don't have legal, clinical, scientific, ethical reasons not to do this, the default is now you will share. So we think about Cloud Lab as a systematic way to comply with the NIH policy. Imagine that the artifacts being produced in Cloud Lab are automatically deposited into the various data repositories that NIH offers, or the institutional repository, GitHub, that CMU supports. This is a programmatic way to be compliant with this kind of policy rather than the sort of more idiosyncratic person-at-a-time way. Moving, again, more to the right. What happens when the code becomes available? And what happens when you share the code in a way that allows people to participate? There's a lab at CMU called the Robomechanics Lab. As you can see from this picture, they focus on four-legged robots, or quad robots as they're called. So the very first research project I had when I worked at the Hopkins Library was a robotics project. We were going to build a robot that would navigate remote facilities and scan materials automatically and on demand. And then the Google book search happened, and they decided to digitize millions of books. But nonetheless, there were some interesting robotics problems that I was exploring with a friend of mine from college, who is a professor of mechanical engineering and expertise in robotics. And he said something to me at that time that stuck with me. He said, a lot of people like humanoid robots. They like, little puppy robots. They like those kinds of things because they're familiar and because they are less threatening in many ways. But if you design a robot for functions, they don't necessarily look like people, right? He said, when you go from beating clothes on a rock to clean it to having a washing machine, you don't build a robot that beats clothes against a rock. You build a washing machine, right? So quad robotics is kind of this recognition of what is the best form of robotic function without being tied too much to, is it humanoid, is it this? And they're designed specifically to work in the real world environments, moving out of the lab into the real world. This group at CMU basically realized they were building software repeatedly in order to do their work, and came to this conclusion that every team that is working on four-legged or quad robotics must be facing this issue. So they built an open source software stack and released it. And it's available on GitHub, and anyone can use it now. This is going to save not only their lab a lot of time and effort, but any lab that is doing quad or four-legged robotics. This is a wonderful contribution. Now, I haven't followed up with this lab because my question is, what has happened since you've done that? So when I was in graduate school, we received some data from a hurricane that came through North Carolina. And I was part of the team that put it on, if you remember, if you're old enough, an FTP server, and just made it available to the world. What a wonderful thing we did, right? Suddenly I'm getting emails from people all over the world saying, hey, what does this column mean? Does that look like an error, and so on? And I became a full-time data support person. So I wonder if this lab, the unintended consequence ends up that you have a lot of support issues, that you have a lot of people asking you for help. How do you help support a team that's trying to do the right thing, trying to do something useful, build a community around that so that it can be maintained, it can be sustained? This is a key function of the Open Source Programs Office that we've launched out of CMU. We don't want scientists and engineers to spend all this time doing this work. We want them to be able to say, we are in some sense handing this off to you as trusted partners in the library to do this. I just tell you quite candidly, one of the most moving things I heard from Alex Saleh was he gave a presentation where he said, the Sloan Digital Skyscraper is my life's work. And I'm trusting Sayeed to be the long-term curator of this. And I said, so when he says me, he means the library, not just me. There's a lot of people that will be working on this. But that conveyance of trust is a key part of why I think people trust and want to work with the library in terms of building this kind of long-term support. So this individual you see here is Omar Mohsin. He's the open source coordinator at the United Nations. And he told me a story that I want to share with all of you. The United Nations has these hackathons, sort of open source contests. One of them was around software to study electrical grids, which was developed by, he didn't give me the name of the university, he said the Swedish equivalent of MIT. So if you know what that is, please let me know. But he said they produced the software to track the electricity grid and study impacts and how you optimize it and so on. The software had a resolution of 10 kilometers by 10 kilometers, 100 square kilometers, and it took 12 hours for each run. So they opened this up to a contest and said, hey, everybody, we have this open source software, it does this thing. You know, can you make it better? Can you improve this? A month later, they heard from a young woman in India who said, you know, you had this contest around this software from this Swedish university. Here's my interpretation or my contribution to this. They looked at it. The resolution of her code worked at 2.5 kilometers by 2.5 kilometers, much finer resolution, and it only took 30 minutes to run. So I could only imagine the reaction of the original software development team. But to their credit, they said, this is fantastic. And they embraced it and said, sure, we will incorporate this. We will update the software. She was invited with her father to the United Nations to get an award about this. Apparently the Secretary General met them. And as she and her father left the building, apparently everybody was crying. They were overwhelmed. And she said, this is the happiest day of my life. So I appreciate Omar sharing the story with me, and this is the next stage to me of what happens when you make code available. We, as engineers, I think at some level are taught that it's a team dynamic, it's a team sport. My first degree is in civil engineering. Nobody builds a bridge borrowing a component from someone you do not know and just incorporating it into an existing design process. There's a team that works on this. There's specifications. There's the waterfall methodology. Take whatever metaphor you want. We now live in an age where an individual can produce code that is used by Microsoft, that is used by Carnegie Mellon. So it is a transformative type of opportunity, right, to have individuals making this kind of contribution. How do we manage this process is something that I think will be critical. How do you take individual contributions from outside of the formal university structure, incorporate it into a community, and then make this kind of transformative types of impact? So just a few key thoughts in terms of what can I do as an individual? So a lot of the things that I've seen, not only about open source in the Arab world, but in the US and in Europe, rightly focus on large-scale infrastructure, on policies, on strategies, on funding. All of those things are important, absolutely. I'm not in any way trying to imply that they are not. But what can you, as an individual, do, right? And so these are just some thoughts and ideas that I wanted to share with you. So one of them is open by default. That's not my idea. That's the idea of the United States Department of Defense. They have issued a memo about open source software, and it states clearly we should be open by default, both in terms of the software we consume and both in terms of the software we produce. Now, I attended a workshop where the writer of this memo presented, and as you might imagine, people were asking him, really? The Department of Defense is going to be open by default? And he said that we will lose more than we gain if we try to close this off. That there's so much available in the open source ecosystem, we simply have to figure out how to work with it. And that we're not going to be able to somehow hermetically seal the software developed by the DoD and pretend it doesn't exist in this larger context. So my sense is if the United States Department of Defense can be open by default, then universities maybe okay being open by default. The other is consider openness at every stage. And this really goes to that data flow diagram, right? If the astronomers hadn't thought intentionally at every single stage, what does it mean to make decisions about the database schemas, the metadata, the identifiers, in terms of ultimately we want people to use them that have nothing to do with astronomy or nothing to do with the core astronomy team. It changes how you approach the development of those data flows and how you organize the data and the code that you write. Is it open or is it not? So thinking about that openness at every stage is critical. If something is a completely closed process and then suddenly you decide at the end you want to make it open, you have a much higher activation energy in order to make that happen. Whereas if incrementally you've made those decisions, it's far easier. And that openness is not also binary, right? Not everything has to be open, not everything has to be closed. Josh Greenberg, who's a program officer at the Alfred P. Sloan Foundation, has this wonderful term called the rolling wall of openness, right? Is that at any point in that data flow or any point in your code development, maybe you're open, maybe you're not. Or maybe you're open after some period of time. The term has become somewhat negative because of when it's applied to publications, but embargoes. There are good reasons to embargo data. Even the astronomers embargo their data so that they can do the analysis initially. If you spend time and energy acquiring the data and analyzing it, you deserve to have an opportunity to write the first papers and get the credit for that. So embargoes are not necessarily a bad word or a dirty term or so on. And it implies that you can still prepare to be open, close it for a while, and then open it later. But if you haven't made that as an option, then your moment has passed. I'm going to talk particularly, or make a pitch particularly about identifiers. So my research area has been infrastructure design, and I think one of the things that we've noticed about historical infrastructure development is they tend to be regional systems first, and they cohere into infrastructure when there's a key piece or key standard that falls into place. So in the case of the United States, I live in Baltimore, where there's the Baltimore and Ohio Railroad. There was the Pacific Railroad. When somebody said we need to get rail from the Atlantic Ocean to the Pacific Ocean, everybody sat down and said, what's the railroad gauge, right? So that we can all work to that gauge. TCP/IP is a great example of that for the internet. You may remember early variants of networking protocols. IBM had one called Token Ring, and there was OSI and so on. All of them disappeared when TCP/IP came along. It was designed to be a global protocol. It basically eliminated all the local variants. In some sense, that's what identifiers are, right? They give us an opportunity to think about what is that key piece that will connect open science infrastructure, particularly for working with machines, working with computers. So the ChatGPTs of the world right now are being fed data, right, that have contained sort of data set. Eventually, they will reach out, right, into other sorts of data, and they will do that through knowledge graphs, right? They're not going to sit there and search the way we do. They're just going to traverse these knowledge graphs. If you don't have an identifier for yourself by an ORCID, or you don't have an identifier for your data, or eventually your software, you can't be on a knowledge graph, right? So as these AI tools progress, you simply won't exist in the way that they will traverse their knowledge graphs. And you probably gathered that I think it's a good idea for you to partner with your library. So one of the reasons I came to CMU was Keith has been thinking about open science for decades, certainly at CMU for at least 10 years, and has built a team and a set of colleagues who are all rallied around this, and I wanted to be part of that. But this is true of any of your libraries. They may be at different stages of maturity or different stages of evolution, but it is a role that really fits naturally with the mission of the library. And it is a direction that fits very well with what I will call libraries that are thinking strategically about open science. So I'm going to come back to this slide, and I'm going to give you one more story. So In this part of the world, some of you may know or may already know this story, but I suspect some of you won't. So Adam Smith, and apologies to Keith and any other Scott in the room. Adam Smith is often called the father of modern economics, right? Joseph Schumpeter, who was another economist, wrote a book in 1954, I believe, called The History of Economic Analysis, in which he points out Ibn Khaldun and says there is a huge gap in economic history. Hundreds of years before Adam Smith wrote The Wealth of Nations, Ibn Khaldun was talking about these ideas and wrote down division of labor and talked about social sciences more broadly. That recognition didn't happen for hundreds of years, right? So here was an idea that came out of the Arab world. We didn't have orchids, we didn't have DOIs. I'm not implying Adam Smith deliberately read these things and denied them. But why did that gap exist, right? So in addition to the interest and the curiosity that you have coming out of the Arab world, there's tremendous talent in the Arab world, as there is in every region of the world. We don't want to wait hundreds of years, even decades, even years, for the knowledge that's coming out of this region to disseminate, to permeate, to sort of percolate throughout the whole world. We have the tools now. We have the institutions to help. It takes effort, but I hope I convince you that the effort is worth it. And that ultimately, open science is really about sharing stories. And I hope that you agree with me, it's worth sharing our stories with each other. So with that, I would be happy to take any questions or have discussion or ideas. I have released this using a Creative Commons license just to show you that I embrace them. And I'd be happy to have a conversation. And I believe, Tatiana, you'll be helping us do that. So thank you.
Well, thank you. Is it working?
You may have to turn on, yeah.
Thank you, Sayeed. First of all, after sleepless, it doesn't work, I guess. Thank you, Sayeed. First of all, really congratulations. After sleepless night, you really proved to be a very engaging storyteller. Okay. Yeah, it was really interesting to see all the stories you gave to us. First, the dashboard about COVID from Johns Hopkins University, then which was Sloan Digital Sky Survey, robot blowing puffs of air, which is kind of interesting as well, and the last one about UN competition. So it's kind of interesting message that you gave that whenever you release in the world the open source software, articles, whatever it is, it actually starts to build bridges between communities, between science and people, between countries, and it starts the grassroots movement that actually refines software, that put it into use into the community and actually makes transformative impact. And thank you very much for reminding us that we need to have DOI, we need to have ORCID ID, because with new technologies coming, we will not be visible if we don't have these identifiers. It's a good warning. Well, now, after this very interesting presentation, I open floor for questions. Oh.
I think I can use this microphone. Thank you, that was very, very, very interesting. I have actually a couple questions, kind of related. So with the exception of the Johns Hopkins story, most of these stories are coming from big, institutions. Yes. We're not talking about university here or there that are, opening up their data or software. Right. How practical is this actually? I mean, these are also, I'm guessing they have their own funding sources. They're not relying on NIH or this or that for their funding, which lead to when you're a scientist, you're a researcher who want to open, right. Your data, your articles, whatever it is, and that the funding agency is putting restrictions on you. Mm-hmm. I mean, I love that the NIH is starting to do this open source thing, but that does not seem to be the common practice worldwide. Yeah. And how do we kind of manage between these two?
Yeah. No, it's a really important point, and funding is critical in all this. But I will say that even for the funders, they're asking two very important questions, right? So one of the things we heard about COVID, why did articles get released? Why were people sharing? Why was there so much preprints and so on? Is, well, because COVID was important, right? Well, so is cancer, so is Alzheimer's, so is climate change, so is food insecurity, so on. While COVID was an incredible accomplishment, celebration of university research, open science, and then direct impact on people's everyday lives, obviously funders are asking, why can't you do that again? Why does it have to be this one-time event? And I understand there was a certain urgency, it was worldwide, I get all of that. But the reality is the funders have now seen firsthand that this is possible. And they're starting to ask the question, what other ways, what other mechanisms, what other projects could this be possible? The other thing funders are also beginning to do is ask about sort of a model for how grants are given. At least in the US, there was a National Academy of Science roundtable on aligning incentives for open science. And I was struck by university presidents saying, we have a superstar culture, right? We have this one principal investigator, project director, take your pick, who then gets junior faculty, graduate students, and so on, and builds a team, a lab, and so on. Is that really conducive to solving large-scale problems? Do we need to bring in all the other kinds of institutions that you just described? Johns Hopkins, Carnegie Mellon, or so-called R1 institutions in the United States to this classification system. What about other types of universities? What about the community members, right? So the funders are looking at these questions and also asking, how do these things get sustained, right? So one of the things the library at Johns Hopkins has done is taken some of the data releases from the Sloan Digital Sky Survey and preserved them, right? And they're doing that with the funding from the library, from the university. So how do we find ways to sort of transition also not just the trust and the data, but the funding mechanisms as well?
Hey, my related question is, I haven't been doing science for a long time, but long enough to think that we actually used to be open by default.
Yes.
And we're actually we're going the other way around,
Right.
at the university levels.
Yeah.
I mean, Carnegie Mellon University, one example, what I've been working on for years, there's a big push to actually not publish your data till you protect it, till you do these patents or whatever it is. And how is the university, and if I use just Carnegie Mellon University as an example, and this is in other places as well,
Yeah.
How do they actually, I don't know, on one hand, they're telling us, open science is very important, and I agree with that fully.
Sure.
And on the other hand, say, well, don't even open your mouth before you talk to some other office
Right.
and see if you can protect your data and embargo it or do whatever you need to do with it.
Yeah, no, absolutely. You're right that there's tension, there's trade-offs here. So I think it's interesting you say about being open by default and sort of losing their way. Open source came out of universities, right? But it's the private sector over the last 10, 15, 20 years that's really advanced a lot of open source. But one advantage that we have with open source is there are already existing licenses, right? So the Creative Commons is sort of a bend from articles into data. Those licenses exist for software, and they allow degrees of permissiveness, is the term that people in the open source community use, all the way from fully commercial to no commercial, right? Are there lessons we can learn from that with data? Are there lessons we can learn with that with other kinds of artifacts, I'll call them that, right, that are produced out of universities? And I will say that at Carnegie Mellon, the Technology Transfer Group, the CTEC, the Center for Technology and Enterprise Creation, I think that's right, is open to this idea that there are different kinds of impact, right? And I will say the director of that organization, Bob Woolrich, used the term, I kept using the term translation. So those arrows at the right side of that diagram, I used to talk about the translation of research outside the walls of the university. And he stopped me and he said, well, aren't you just talking about dissemination? And shouldn't we be more focused on dissemination of the products of Carnegie Mellon? Now, keep in mind that their incentives are also important, right? So he pointed out, we are judged by how many disclosures we have, how many patents we produce. If we can change those metrics or add new metrics, then we will respond, right? And in the US, there was legislation, I think it was 1980, the Bayh-Dole Act, in many ways launched the sort of technology transfer movement in the United States. I've already asked the question to several people, what's the next version of the Bayh-Dole Act? So if the federal government really believes universities need to be more directly impactful in everyone's lives, everyday lives, then we may need a new version of that or an extension to that. So I'm not saying it's easy, but I think there is some interest and there is some will, and there may be some mechanisms to make it happen.
Does CMU have any plans for something similar to, say, MIT OpenCourseWare?
That is a good question. I actually don't know the answer to that. I'm not sure. Keith, you or Mike, do you know?
I think we will see more of that. We are on the cusp now of looking at online program delivery at the graduate level, and that, I think, is really going to be the catalyst that will lead to more course material being released openly. We've had the OLI platform, which is adopted by universities around the world for many, many years. It's the content we've been slow to release. So I think we will see more coming out in the next while. And if I could just, whilst I've got this on, come back to the point about the CMU posture around data sharing. The Faculty Senate about 8 years ago adopted a resolution to encourage data sharing and really tried to recognize but identify a fairly narrow scope through which data might be withheld for commercialization reasons, in addition, obviously, to legal or other industry sponsorship reasons. So I'm hoping that we will be able to remind people that the Faculty Senate has been there for some time and is encouraging data sharing.
No more questions?
Yeah, of course.
I really find this very interesting, so I want to pick your brain on this. On the identifier part, and I agree with you, this is one story. There are actually many stories of, if you go back, you find a lot of scientists a long time ago who discovered the same thing, they were not recognized. But even for nowadays, the language barrier, English is the language of science now, and if you don't publish in English, you don't get recognized. Is there a way? These identifiers don't solve that problem, right? Is there a way to solve the problem of, if I publish something in Arabic, would it be recognized and disseminated the same way as something that's published in English? Or is there a library automatically translate things?
Well, Mike and I were having a conversation earlier about translation through AI, right? I mean, this is a field where I think there's a lot of potential there. You're correct that the identifiers don't solve that problem. But I think what the identifier does is it puts a citation chain in place, right? So you could cite an Arabic article. You may not be able to, I couldn't read it, for example, right? But at least I know it exists. And the metadata, and there are also certainly issues around that as well, can possibly help bridge the discovery at that level, right? So at least I know it exists, right? So as a graduate student, one of the things we have to do is, has anyone else done this, right? It's one of the fundamental questions. So at least it can address that kind of level, even if I can't necessarily read it. But I do think we'll have to look to tools like AI in order to do the translation.
I can add something to that as a data point is, I think 2022, one of the top conferences in computational linguistics had this initiative where any paper submitted and presented would be available to any other language through automatic translation on demand. And I think this is going to keep on increasing, and CMU will have some, I think, impact in that.
Thank you for that.
Thank you very much for being here, for your attention, for your questions. I think after this presentation, we will have reception. So if you have some questions that you want to ask, you will have a chance to talk to speaker. But right now, I would like you to stay because as Gloriana Sancler lecture usually concludes with a token of attention given to a speaker, we have the same tradition, still alive. So.
So we're going to stand over here. Thank you very much. So thank you so much for giving such a wonderful talk, such an insightful and clearly part of 21st century librarianship. So thank you so much. Can I ask the two of you to come up and join also for a picture?